Good morning, Wolfpack, and welcome back to lesson 3.3, Dilations. You should have already watched the first two videos, and we are on the last page of our notes. So we're going to finish out the last couple of problems before you do some practice work on your own. So we are on the try it. It says, find a sequence of similarity transformations that maps A, B, D, C to E, F, H, G. Write the coordinate notation, which is the coordinate rule for the sequence. If you notice, ABDC was dilated to EFHG. And as I said on the last problem, you always need to dilate first. If you start moving stuff around or reflecting or translating or rotating before you've dilated, you might do double work. So the one thing that you always want to do is dilate first. So we need to find the scale factor. Scale factor is image over pre-image. So here is the length of my image, and it is at 2 because it's at halfway here and halfway here. So it's 2, and the pre-image is at 4. So it was dilated to a half. There's our scale factor. And then you're going to write down your coordinates. So I'm going to write down A, B, C, and D. I want you to go ahead and pause the video and write down the coordinates from A, B, C, and D on your notes, and then press play again. Okay, so we have A at 1, 6. We have B at 5, 6. We have C at -2, 2, and D at 2, 2. Okay? So what we need to do now is start writing our coordinate notation. And oops, grabbed the wrong thing. So I'm actually going to erase this now that we know the scale factor is 1/2. And just write that over here because we're going to need some more white space. So the first part of coordinate notation is always x, y. And then we found that our scale factor was 1/2. So our dilation is 1/2 x. 1/2 y. So I need to take all of my points and apply the scale factor to them. So I'm going to cut them in half. So 1/2 of 1 is obviously 1/2. Half of 6 is 3. Go ahead and pause the video and please dilate B, C, and D by the scale factor of 1/2 and write the new points. You should have 1/2 3, 5 halves 3, -1 1, and 1 1. So let's go ahead and plot those points and see what we're looking at. See where it lands us. So I have 1/2 3, so it's going to be right about there. And again, I know that I'm doing from the smartboard, so it's going to not be as perfectly straight as it needs to be. But I expect yours to be perfectly straight and perfectly on the lines because you're on a pencil and a paper. 5 halves is 2.5. So 2.5 on the x-axis, 3 on the y-axis. So again, right about there, should be a little farther up. -1 1 and 1 1. Go ahead and connect your points. And there's your shape. As you can see, it looks to be about the same size. It's has a length of 2 on the top and bottom. But now I need to move it. I'm not going to need to reflect it. It's facing the right direction. Not going to need to rotate it. I'm just simply going to need to translate it. So I need to figure out, and I'm going to run out of room, so I'm just going to draw a little arrow. I need to figure out now how much I'm going to translate it by. What am I going to do to the x? What am I going to do to the y? Okay? So it's at half. So this point, this point right here is at half, and E is at 2.5. So half to 2.5, I'm going to move it to the right, 2. And then A, this point right here is at 3, and it needs to come down to 0 on the x-axis, so it's going to move down. I'm sorry, on the y-axis, it needs to move down 3. So if I move every point to the right 2 and down 3, it should map to E, F, G, H. So starting right here, 1, 2, down 1, 2, 3. Sure enough, landed right here. Starting right here to the right 2, 1, 2, down 1, 2, 3, and so on. And if you repeat that it maps right where it needs to be. We have done this multiple times. The only change that we're doing now is dilating, but even then, we've done dilating before as well. So we dilated it, and then we translated it. Make sure you dilate first. The answer is the coordinate rule. You need to make sure that's what you wrote down. This is our starting point. This is our dilation. This is our translation. If you have any questions, make sure you're writing them over in your margins. Last section, notes. A blank transformation is a transformation in which an image has the same shape as its pre-image. That's called a similarity transformation. Notice it has the same shape. It does not say it's the same size anymore. Similarity transformations include reflections, translations, rotations, and dilations. Two plane figures are similar if and only if one figure can be mapped to the other through one or more transformations, similarity transformations. So if I can take a shape and I can dilate it then reflect it, or translate it then rotate it, or dilate it then rotate it onto the other shape, then the two shapes are similar. If I can't get it to map onto it, to lay perfectly on top, they are not similar. Let's put this into action. Determine whether the figures are similar using similarity transformations. Now, if you notice, the bigger shape is named CFED, and the smaller shape is named TFVU, and we don't know which one mapped to which one. But I have told you before, if it does not tell you which one maps to which, go alphabetically. So we're going to assume here that the bigger shape mapped to the smaller shape. Okay? So can I do something to CFED to map it onto TFVU? Can I do something with that? Well, first of all, let's look at the scale factor. So the scale factor is image over pre-image. Look at the straight side of TFVU. What is the length of TF? That's the image. TF is 3. What is the length of CF? Its corresponding side. CF is 6. So it looks to be that it was dilated by half. It was cut in half. So I'm going to write that down as my scale factor. So now I want you to write down C, F, E, and D. Oh, going the wrong way. C, F, E, D. I want you to write the coordinates of those points. Go ahead and pause the video and write down the coordinates of C, F, E, and D. You should have written down that C is at -3, 2, F is at 3, 2, E is at 1, -2, and D is at -5, -2. So now we're going to dilate it, and we already found that our scale factor was 1/2. So I'm going to take all of these points, and I'm going to cut them in half. So this becomes -3 over 2, 1. 2 times a half, or 2 divided by 2, is 1. This becomes 3/2, 1. This becomes 1/2, -1. And D becomes -5/2, -1. So you have negative, where am I at? Let's see, you have -3/2, 1, you have 3/2, 1, 1/2, -1, and -5/2, -1. So you need to go ahead and plot that image, our dilated image, on your graph. So go ahead and take a moment, pause the video, and plot these new coordinates on the coordinate plane. Okay, I just plotted those points in the red. You can see that I plotted them. Hopefully yours is a little neater than mine, but I think you probably did a great job. So now we have to figure out how we can get my red shape mapped to my final green shape. Let's recap what we've done so far. We started off with X, Y, and then we dilated. And we dilated by the scale factor of 1/2. So we did 1/2 X, 1/2 Y. And we're almost there. I'm going to run out of room again, so I'm just going to loop it around. what's my last step? I need to map, and let's call this, we'll call this C prime. I need to map C prime over to T. Well, I see that C prime is at -3/2, and I need to map it to right here, which is at 0, 2, it looks to be. So I'm going to have to move it to the right and move it up. So if I'm going to move it to the right, I move it here, that's +1 from -3/2 to -1/2, and then move it one more over to 0 on the x-axis. So I'm going to add 3/2, or you could call it 1.5, and then it's right here, and I need to go up 1. So I'm going to add 1 to the y. And if I do that to all of my red points, they should map to all of my green points. So I added 1/2 to all the x coordinates, and I added 1 to all of the y coordinates. And this is your coordinate notation. Am I going to be able to make my red shape map perfectly onto my green shape? Yes, I will. And was I able to do it by using transformations? Yes, I used a dilation, and then I used a translation. Both of those are transformations. So that means all of those shapes are similar to each other. Okay, C is similar, CFED is similar to TFVU because I was able to take CFED, dilate it, and move it to land right on top of TFVU. One more problem, and then we are done for the day. Example 6. Find a sequence of similarity transformations that maps the pre-image to the image. Write the coordinate notation, also called the coordinate rule, for the sequence. The first thing you need to do is find the scale factor. Again, scale factor is image over pre-image. The length, and you can, it's kind of small, but you can see that the smaller shape is the image, the smaller shape is the pre-image, the larger shape is the image because the larger shape is marked with prime. So the length of the straight line is 1, 2, 3, 4, 5, 6, 7. And the length of this straight line is 14. So my scale factor is 2. And before I run out of room, I'm going to write my coordinate notation here, because I'm running out of room when I'm doing it afterwards. So the first thing we're going to do is we're going to dilate the shape. Okay, so I know I'm going to multiply it by the scale factor of 2. I just found the scale factor of 2. And then I'm going to have to keep going somewhere. So you needed to go ahead and pause the video, and I want you to write down the coordinates of A, B, and C. So where's A starting? Where's B starting? Where is C starting? Go ahead and pause the video, and we'll go from there. Okay, you should have written down that A is at -6, 7, B is at 1, -7, and C is at -4, -4. Now we're going to apply our dilation to it. So we have -12, -14. We have 2, -14, and we have -8, -8. And we're not going to really be able to graph that because our graph is not big enough. So we're at a little bit of a disadvantage, but it's okay. We're going to get there. Basically, we can see that it's still facing the same direction as it originally was, but it's going to be bigger now. Okay? Now, I can tell that I'm going to have to flip this. I'm going to have to reflect. So if you see AC is on the left here, and A prime, C prime is on the right here. So I'm going to have to reflect over something. And I would suggest, just to keep it easy, let's reflect it over the y-axis. So the rule for reflecting over the y-axis is x gets a new sign, y stays the same. So all of these coordinates, let's give x the new sign, and y is going to stay the same. So this is going to be now 12, -14. It's going to be -2, -14, and this is going to be 8, -8. Okay, so now I reflected it. So again, I know we're visualizing this, but I made it bigger And now they're at least facing the same direction. And the way you can do this without graphing it is you're going to have to compare points. So let's figure out, where do the points end up? Where is A prime? Where is B prime? And where is C prime? So A prime is at 8, -4. Right here, if you count your points, A prime is at 8, -4. B prime is at -6, -4. And C prime is at 4, 2. Well, you have to compare. I obviously did something after the reflection to get it there. So what did I do to 12 to get it to 8? What did I do to -2 to get it to -6? What did I do to 8 to get it to 4? Well, what's the difference between 12 and 8? It's -4. So I subtracted 4 from all the x coordinates. 12 minus 4 is 8. -2 minus 4 is -6. 8 minus 4 is 4. And then I did something to the -14 to make it -4. And it looks like I added 10, because -14 plus 10 is -4, and -8 plus 10 is +2. So that final piece is a translation. So I was able to prove that the ABC triangle was similar to A prime, B prime, C prime, because if I dilate it, and then I reflect it, and then I translate it, they will map right onto each other. And this was definitely a challenging one because we were not able to graph it in entirety because the graph was too small. But we knew we had to make it bigger. We knew we had to reflect it because it wasn't facing the same direction. So the hardest part was in comparing our third set of points to our fourth set of points and figuring out what the difference was. Okay? If you have any questions at all, please make sure you're writing them in your margins. Hope you have a great day, Wolfpack, and I will see you next class.